Today we're going to discuss inverse functions and how to find them. I've placed over here on the side a set of 4 steps that I want you to write down at this time. The first step is to replace the g of x with y. The second step is to swap the x and the y values. The third step is to solve for y. And fourth is to rewrite in function notation. Please pause the video at this moment if you are not finished writing these 4 steps down. We're going to do this function and find the inverse function of g of x equals 3x plus 5. This is function notation. This g of x is a fancy way of writing our y value. So I'm going to replace that with y equals 3x plus 5. This is a linear version, and this is function notation. Now, that's our first step. Our second step is to then swap these x and y values. So I'm now going to rewrite this as x equals 3y plus 5. That's step 2. Step 3 is to solve for y. I need to isolate the y variable. So I do that by doing the inverse operation for everything on the side here with the y. The inverse of adding 5 is subtracting 5. Don't forget, whatever I do to one side of the equation, I must do to the other. So I get x minus 5 is equal to 3y. Well, I've almost isolated my variable y, but not quite. I've got to get rid of the 3 in 3 times y. Well, the inverse operation for multiplication is division. So I will divide both sides by 3. My 3's will cancel, and I get that y equals x minus 5 over 3. Well, I found the inverse, but now I need to write it in function notation. I'm going to slide the screen up just a little bit. Function notation is changing this back into g of x. But I don't want to write it as the exact same as this g of x. So the inverse function has a special notation. G with a little -1 of x is equal to x minus 5 divided by 3. That is the inverse function. This is inverse notation. So let's do another. Okay, our next example. I still have my steps written over here on the side so that I can refer back to them if I need to. The first thing I'm going to do is replace my f of x or g of x, in this case f of x, with a y. So y equals x minus 2 cubed. Now I need to swap the x and the y value, still the same exact steps, even though my equation looks a little different. So I have x equals, parenthesis, y minus 2 cubed. The next step is for me to solve for y. In this case, to solve for y, I need to start on the outside and work my way in. Start on the outside and work my way in. Well, the inverse of taking a cube is a cubed root, taking the root. So I can take the cubed root of both sides. That's the inverse operation. So I'll have the cubed root of x is equal to y minus 2. The cubed root of x would equal y minus 2. Again, I work from the outside in. My y is almost isolated. It is almost by itself. I have to get rid of the minus 2. Well, the inverse of minus 2 is to add 2. In this case, my 2's will cancel, and I get y equals the cubed root of x, and then the plus 2 is outside the radical. Please make certain that you keep it outside the radical. You don't want to slide it inside. Well, now I've solved for y. Now I need to write it back into function notation, and I need to use the inverse notation. Well, inverse notation is my f, just like I have here, to the negative 1 of x. That's read as the inverse function of x is equal to, let's slide up a little bit, the cubed root of x plus 2. Again, I do these 4 steps. I replaced the f of x with y. I swapped the x and the y. Notice that's there on the inside. And then my step 3, I began solving for y. I took the cubed root because I needed to get rid of this cube. So I took the cubed root of both sides. So these two things cancel each other out. They are inverse operations. So I had the cubed root of x is equal to y minus 2. The inverse of minus 2 is to add 2. So I added 2 to both sides. I get the cubed root of x plus 2 is my y. And then I'm going to write it back in inverse notation. The inverse of x, the inverse function, inverse of f of x is equal to the cubed root of x plus 2. Let's go through and do another example. Let me slide this out of the way. Oh, sorry. Let's keep our steps over here so that we have them handy and can refer back if we need to. So again, I'm going to replace my f of x with y. Oh, let me take a second and I'll give you a moment to write this down. Okay, so y equals 2 times the square root of x plus 3. Notice the x plus 3 is inside the radical. It is important to notice this. Now I'm going to go to step 2, which is to swap the x and the y. So x equals 2 times the square root of y plus 3. Now I want to get the y by itself. I need to isolate the y. Well, I always start on the outside and work your way into the y. Well, on the outside is this 2. It's 2 times this. So the inverse of that is to divide by 2. So I'm going to divide both sides by 2. So I get x divided by 2 is equal to the square root of y plus 3. X divided by 2 is equal to the square root of y plus 3. Again, I need to keep going so that I can solve for y. On the outside, I have a square root. The inverse of a square root is to square it. So I'm going to raise it to the power of 2. When I square this, I'm going to get x times x, which is x squared, over 2 times 2, which is 4, and that's going to equal my y plus 3. This square takes care of the radical. Now my y is almost isolated. I just need to get rid of the plus 3. The inverse of adding 3 is subtracting 3. So I have the fraction x squared over 4 minus 3 is equal to my y. Again, I want to rewrite it back into function notation using my inverse notation. So I'm going to use the inverse of f of x. I'm going to slide this over so I can slide up a little bit more. So the inverse of f of x is going to equal x squared over 4 minus 3. And that's how I do an inverse function. These 4 steps are the steps that you need to find the inverse. Thank you.